viewers and learners, wherever you are. Today we want to look at matrices, specifically multiplication of matrices. We want to see how do we multiply matrices. Last time we looked at addition and subtraction of matrices. So now, how is multiplication of matrices done? Now, in the multiplication of matrix, we need to look at, first of all, the multiplication of a matrix by a scalar or by any number that is a scalar. So, for example, a matrix A can be multiplied by a scalar K. The scalar multiplies each and every element inside the matrix. Remember last time we talked about the elements inside a matrix. So the scalar is going to be multiplied by each and every element that inside that matrix. For example, if you have a matrix B as A, B, C, D, and it is being multiplied by a scalar K, then it means that KB, that is the scalar K and the matrix B, should give us K multiplied by A, K multiplied by B, K multiplied by C, K multiplied by D. So the scalar K is going to multiply with each and every element inside the matrix. For example, given a matrix T as 5, 2, 6, 4, 7, 9, find part A of it, a half of T, and then part B of it, 3T. So half of T means that, let's create more space, it means that we will take each and every element inside the matrix and multiply it with a half. 5 multiplied by a half, 2 multiplied by a half, 6 multiplied by a half, 4 multiplied by a half, 7 multiplied by a half, and 9 multiplied by a half. And this one translates to 2.5, 1, 3, 2, 3.5, and then 4.5. So that's how you multiply a matrix with a scalar. So for the second bit, that is 3T, that means you take each and every element inside the matrix and you multiply with the 3. So for this particular sum, you can try it out as an assignment, then you can post your answers below. Now, that one said and done, we want to look at the second bit, and that is multiplication of a matrix by another matrix. How do we multiply one matrix and the other matrix? There is something you need to note. Before we multiply a matrix and another matrix, first of all, for matrix A to be multiplied to matrix B, then the two matrices must be compatible. They must be compatible. What do we mean by two matrices being compatible? That means the number of columns in the first matrix must be equal to the number of rows in the second matrix. Remember, we said a matrix is defined by the number of rows and the number of columns. So if you count the number of columns in the first matrix, it must equal to the number of rows in the second matrix for those two matrices to be multiplyable. So they have to be compatible. That means conformable. For example, if you have a matrix AB being multiplied by a certain matrix CD, if we look at the first matrix AB, we can see it has one row, but now we'll base ourselves more on the columns because the first matrix column must equal to the second matrix rows. So this one has two columns. The second matrix has one column, but it has two rows. So it is in agreement with our condition that the number of columns in the first matrix must be equal to the number of rows in the second matrix. So you can see that this one can be multiplyable. Look at the second example, XYZU. It is being multiplied with the PRQS. This one also, the first matrix has two columns. The second matrix has two rows. So this one also can be multiplyable. Let us look at the third one, ABCDE. DEF. It is being multiplied with the PRQS. The first matrix has 3 columns. The second matrix has 2 columns. So this one is not compatible, so it cannot be multiplied. So the third matrix cannot be multiplied, but the first and the second matrices can be multiplied. We go ahead and see how do we multiply a matrix by another matrix. Now, for example, if you have a matrix 2, 5, 4, 2, 9, 6, it is being multiplied by 6, 0, negative 2, 5, 3, 2. Now, the first matrix has 3 columns. The second matrix has 3 rows. So they are compatible, so they can be multiplied. Now, you will note the colors I've used here, in that the first element in the first matrix in the first column is being multiplied by the first element in the second matrix in the first row. What do I mean by that? It means that 2 is going to be multiplied by 6 to get 12, plus 5 multiplied by negative 2, you get negative 10, plus 4 multiplied by 3, you get 12. So we are finished for the first bit of multiplication. We go to the second bit, and that is 2 multiplied by 0, you get 0. You can see as per the color of the numbers appearing, the letters appearing. Then 5 multiplied by 5, you get 25. Then 4 multiplied by 2, you get 8. We go to the next row. 2 multiplied by 6, you get 12. 9 multiplied by negative 2, you get negative 18. Then 6 multiplied by 3, you also get 18. Go to the next. 2 multiplied by 0, you get 0. 9 multiplied by 5, you get 45. Then 6 multiplied by 2, you get 12. And this one translates to 14, 33, 12, 57. So the matrix that we get from multiplying the first one and the second one is the matrix 14, 33, 12, 57. Now, given matrix A is 1, 2, 0, 4, and matrix B is 2, 2, 3, 1, find the matrix AB, that is A multiplied by B, using the rules that we have seen above, the laws that we've seen above. If we multiply matrix A and matrix B, we are going to get 8, 4, 12, 4. What about if you are told to find BA? Let's take matrix B, multiply with matrix A. So this one, using the above rules also, that is 2, 2, 3, 1, multiplied by 1, 2, 0, 4. Multiplying these two matrices, we are going to end up with 2, 12, 3, 10. Now, one thing you should note is that the first matrix AB, it gave us a different matrix from the second matrix BA. So, generally, what does this one mean? There's something you have to note, that generally in matrices, when you take matrix A, you multiply with the matrix B, it is not the same as matrix B multiplied by matrix A. They are not the same. A multiplied by B is not equal to B multiplied by A. Thank you for watching and learning. You can like and subscribe to my YouTube channel, MBC Online Math, and Facebook channel, MBC Online Math. Thank you.